Hi, my name is Damon Rocha, and this is my GPE104 midterm update number 2. So in this video, I wanted to cover the principles of object-oriented programming, variables, movement and vector math, time-based values, loading levels, and persistent data / the singleton pattern. So let's start with object-oriented programming, and out of that, we could begin with encapsulation. Let me just remove this filter and hop over to my blueprints. So for the first part of object-oriented programming, I'm going to look at this BP enemy, and specifically I wanted to use this to point to encapsulation. So this enemy class has all of the variables and methods it needs to run, and it's all wrapped up in this class. The only thing it exposes for others to change or other classes to use are those that are necessary. So like whether it's alive or not, speed and the shot delay, all those can be changed in the editor along with from other classes. Another example of encapsulation is this killed enemy component and health component. Both of these wrap up all their functionality in there, and this enemy class doesn't have to worry about all the code behind these components. Next, onto abstraction. So a good example of abstraction is actually in this health component. So let's open up BP health component. So here in this health component class, whenever we're taking damage, we're going to change the health. And when we change the health, we're going to call this onKilled. We don't need to know what the onKilled does. We don't need to know the code behind it. All that needs to happen is that the parent class of this component, this health component, has to have one of these onKilled interfaces. And as long as it does, it calls this onKilled function, and we don't need to worry about anything behind it. So for a few examples of that, in this enemy killed, when they call their onKilled function, it'll get the owner, say that the enemy's not alive anymore, spawn a blood spatter emitter, wait 0.2 seconds, and then destroy the actor. But the player death we'll call this onPlayer killed in the game mode, which opens up a new level and takes away from their lives. And they're using the same health component. So this abstraction of onKilled allows them to use the same exact code, but the only difference is the way they're implementing their onKilled is different. And now onto polymorphism. One example of polymorphism I wanted to cover, which is just that like the same function can be called in different ways with different parameters, is a usability. So this usability interface can be recreated over and over again in different ways, have it call different functionality and do different things based off of each implementation. But in the end, the consumers are still only going to be calling this usability. So in this example is the time portal component. It's going through and creating a time portal and spawning it in the world. But in another scenario, we have the same thing, but instead of it spawning something, we have like a dash component that makes the player faster, or a heal ability that gives them more health. All this using the same function that just has a different version based off of the implementation. And then lastly, so we got encapsulation, abstraction, polymorphism. I mean, there's a few other examples of polymorphism. So you can look at the actor versus character versus the pawn. They're gonna have a lot of the same functionality and similar functions that will be pretty close to the same, but when called in one, the functions will be a little different. I take in some different parameters, but the name's gonna be the same. All right, and lastly, I wanted to cover inheritance. So inheritance is the idea of having a base class and then having child classes that derive from that base class. So if we have a car or we have a vehicle, and then from that vehicle we have a car, and from the car we can have the Toyota or whatever, and they're each going to share functionality of their parent, but then each child's going to have their own functionality that's the parent won't have as well. I didn't build out many examples of this in this. The one thing I can say is I have this first-person projectile, and I let this be the parent class, and I drive a child class of enemy projectile. And all it does is I take this handle hit actor function that was set up in the parent class, and I'm overriding it in the child class to use this enemy damage variable and to damage the first person character instead of it damaging the enemy. And these both, the child class gets to have all this to share the collision component, the sphere, the projectile movement, like none of that has to be changed between the two. The only difference is really this function and how it looks. And that's it for object-oriented programming variables. So throughout my time building this, I've set up quite a few variables, but in this class alone, in the enemy class alone, I've set up a found player variable that's private, a player variable that's private, and then a live, which is public, so that way this can be changed outside of the enemy class the speed, so it can be changed in the editor. So instead of having to come here recompile every time, I can go to this move player. Instead of having to come here and recompile this and change this value each time, I can instead go in the map and change the speed variable for one of these enemies. So I'll click this guy over here, and I can change the speed, shot delay, and I can change whether it's alive or not. I honestly though I'm thinking about removing that and just setting it like a getter or something to get that instead of making it completely public. But that's an example of variables. And next, let's cover movement. So in the same function, we're going to have this vector addition, vector math and movement. So let's start out in the background. So every tick, if the player value is valid, and this is set on overlap of the outer sphere, then we're going to go through the sequence. First, we're going to rotate to the enemy, so it makes it look like you're looking at it, or like the enemy's looking at you. We're going to rotate to the player and make it look like the enemy's looking at you. And then we're going to shoot at the player and move to the player. So this move to the player takes the player's location and subtracts the location of the enemy, normalizes this so it's a unit vector in the direction of the player, and then we're going to multiply this by the speed to up the magnitude of that vector. And then actually we're multiplying that by this delta second to make this frame rate independent. So it doesn't matter how fast your computer is, this enemy's going to be moving at the same speed no matter your processor. And then I wanted to pass in the x and y values of this vector into adding an offset to the actor. And adding offset is just another way of saying I'm taking the actor's location and I'm adding this vector that I'm making here to that location. And since I didn't want them to lower or rise based off of the player, I just added it to the x and y of the player's movement vector. I can real quick jump into this, but I did use this find relative look at rotation instead of going through all the vector math on that one. But more or less I'm getting the location of the enemy and the location of the player. I'm taking the relative look at rotation from that and interpolating with this delta time as making this, again, frame rate independent at a speed of 5 seconds. So it takes the actor's current rotation and interpolates it to this look at rotation. And then from there, just setting actor rotation. And that is it for movement and vector math. And we actually covered time-based values as well. So good to move on to loading level and persistent data / the singleton pattern. So let's close out all these real quick. I can compile this, not too sure what I did here, but I need that open anyways. And let's open this game instance. So in this game instance, currently I'm only tracking lives. This is a singleton class, just meaning there can only be one, and it's going to persist across the whole play session. So no matter how many levels are loaded, whether we jump from a different level, these lives will persist and can only be changed through this game instance. Now, the location we're actually calling this instance to do anything to these lives is in the game mode. So anytime the player's killed, we decrement the lives are less than or equal to 1, we open the game over level. That's false, then we just restart the first person map level by opening it up again. And there's opening levels. I can real quick show opening levels for game winning. So I tracked this goal variable in the game mode because I wanted anytime someone died for them to have to restart and do like all the goals again. So I decided not to leave that in the game instance. I might add a score variable here later to track, but for now I'm just leaving the goals here. So for this, the goals start out as the number of time shards in the level, and it just takes the length of that array. And every time someone collects one, it takes away from every time the player collects one, takes one away from this. And as long as this is greater than 1, it's not going to do anything. But as soon as it's less than 1, it's going to open this game 1 level. And I just want to real quick run through what I have so far, and then we can finish this up. So as it is, player starts in the corner of the map, and pick up a gun. Your objective is to get all these little red triangles and to not die. But as you can see, parts of the map are blocked off, and there's only so far you can go. But if you look over there in the distance, you see another map. So I'm going to hit F and hit this, and actually end up teleporting to this map by adding an offset to my player using the teleportation node. And that allows me to get past these obstacles that I've set for the player. And the player just has to currently go through the level, kill the enemies, pick up all the time shards, and teleport back and forth, as long as there's nothing blocking. So there's blocking, it'll just stop it. And I'll cover how I went through into that in the next video, but this one's probably getting pretty long at this point. So I will end it here and just get a game over real quick. And died. Let's go through this last one. No. And died. So you died, play again, menu, and we're just going to play up. And that's it. I'll have another video up probably tomorrow or the next day. Hopefully my last one. I'm going to go through and replace all these blocks and boxes with actual assets, add some more sounds, and clean it up a little bit so it's not so bland. And along with that, just probably clean up some old variables and stuff that I said at the beginning and come up with a score. Well, thank you very much.